Okay, this video is just a quick little thing about how to use one of these joypad controllers, like a thing on an Xbox or PlayStation. You've got two potentiometers here, one working in the X direction, one working in the Y direction. This one's also got a push button switch on the pin here, D. But we're not going to look at that. We're just going to look at how to use it as two potentiometers. Hopefully you'll all know what potentiometers are by now. If not, watch one of the other videos on potential dividers. Principle is, first pin you connect to the high voltage, VCC it's called. Third pin you connect to 0 volts or ground. And then the middle pin is the output, depending on where you turn the knob. It's a potential divider, so it'll either give you 0 volts right through to 5 volts. And what we've got here is two of them. So we've got the ground pin here, we've got the 5 volt pin or whatever high voltage you're using, and then we've got the I should have said also the one in the middle called the wiper quite often. And on this one we've got two wipers, so we've got the X variable wiper and the Y variable wiper, so these two here. So how do we program this? Well, it's really easy, and this also applies to if you want to use just a single variable resistor potentiometer like one of these. Do it in exactly the same way, but you just have 3 wires coming off this one, whereas this one you need 4. Like I say, I'm not going to use the push switch for this example, but you can do it as well. So how do we program it? Well, it's really easy. All we're doing here is using one of these expression commands all the way down the line to here. It's quite a versatile function, this one. You can calculate something as well, so you can say A equals B minus 2 or B minus C variable. Or in this case, I'm just assigning a variable X as analog input 1 and a variable Y as analog input 0. There we go. So, and then we'll just go and do an LCD command. Square brackets, remember that means call a variable. So here X equals and then variable X, in which case there's nothing here, so it's just nothing. And then on line 2 I'm doing the same with the Y variable, which is this one here, analog 0. Okay, so in this preview here there's nothing in variable X or Y, so they're just displayed as 0. And that's it. Just bear in mind also we've got our output on the LCD. It's just one output, Q0, and that goes on the little 3-pin thing, which I'm going to show you in a minute. Also we're going to give it a ½ a second pause. So remember, anything less than a second, you don't use the wait command, we use the pause command in milliseconds. And what that does, just gives your eye enough time to read the screen before it gets refreshed again. Now you might think electronic things happen at the speed of light. They don't. In this case they're actually kind of timed. So the string of letters that come out of the LCD come out of one wire. So that has to be a series of noughts and ones, which get deciphered by the chip at the other end on the back of the LCD. And that sequence is timed, and it might actually be quite relatively slow by electronic standards. And you will actually see it being drawn out each frame, each character at a time. So what you want to do is just give it a bit of a pause before it does it again. Otherwise it will just look like a jumble of drawing characters. So it's a good idea just to give a little pause. Depends on how quickly you want that screen to update as well, obviously. And that's it. So because we need a 0 volts for the LCD and this controller, what we're doing here is, this is normally we use this for a servo or an LCD. It's got a 0 volts on the black where the middle pin is. This black cable is 0 volts. This one is 5 volts, and then this one is the signal. So it's the unamplified. It's basically straight out of a PIC. We don't have any transistors in the way. And that will send, normally it will send a pulse, which is decoded by the LCD, and it writes out a string of letters, whatever you've written in the command. Now, because we want 0 volts on this as well, what I've done, rather than plugging this directly into the LCD, this goes onto a breadboard here. So we're using this strip here, the blue line. All of these are connected to 0 volts, assuming I plug the 0 volts into that. And then the same with the red one, the 5 volts, that will plug into there. Which means we can share the 0 volts and 5 volts with these two. So on this thing, if you notice on the other side, you'll have, don't know if you can see that, we've got ground, VCC, X and Y. D is a button when you push it down, but I'm not going to use that for this demo. So ground will share with this rail, that's the first black wire. The red wire will share with the plus volts rail. The yellow one is input X, I believe. Yeah, X goes into analog 1, and the blue one, which is Y, goes into analog 0. I could have done it the other way around, but there you go. So if I plug that in again, just push it in like that, connect the battery, let's see what happens. Okay, so you've got somewhere in the middle of 0 to 255. It should be in the middle, but it says about 101, so it's slightly less than half. If I push it up this way, you can see Y is 0. So obviously this would be that way round, if you can imagine. Going up like that, Y is 250, down, Y is 0. X, if you go right, it's 248, 50. Might want a bit of calibration if you want it exact, but you can use a formula in that. And then X that way, down to 0. Okay, so that's quite a handy little controller using 2 variable resistors, potentiometers.